Hi, this is Miss Litton on a smoking hot Thursday. 7th period review. Say hi.
Hi.
All right. So we are reviewing chapter 34, the nature of ecosystems, because tomorrow we want to get a 1 on our quiz. 100%. All right. So let's cut to the chase on just the main things that I think you will know. Am I frozen? I am frozen. I am totally frozen. Okay, there we go. So, when we look at an ecosystem, there are living parts of the ecosystem and non-living parts of the ecosystem. What do we call the living things? Biotic. And the non-living are? Abiotic. Try not to jump the gun, let everybody think. If we took all living things, we could sort them out. What's 2 big piles we could sort all living things into? I'm looking for another word. Yes, that was the word I was looking for. We could take all those living things and we could put them into 2 big, oh, that doesn't work. We could put them into 2 big things. Producers and what? Consumers. All right? Producers and consumers. Those are our 2 big categories. Producers can take energy, right, from the sun or energy from hydrothermal vents and end up making organic molecules out of it. Who can use those organic molecules?
Consumers.
Consumers. Now, when we look at consumers, we can break those down too. Now, I heard other words out there that also work that end in troph. What were the other words we heard? Heterotroph and autotroph. And I like that too. Now, some heterotrophs are specialized to eat producers. Don't say it out loud, let people think. Some heterotrophs are specialized to eat producers. What can we call those types of heterotrophs? Herbivores. We call them herbivores. We could call them primary consumers because they're on the first level. Now, make that make sense to you so you're not having to what it? Think about, memorize it. Just make it make sense, right? So if I create a page. So I'm making this flower, which happens to be green and unusual. What would we call it? Autotroph. A producer. What else could we call it? Autotroph. We could call it an autotroph. Okay, good. Now, who's going to eat our flower? Give me an animal.
Bunny.
A bunny. Okay, yeah. All right. Because we know I can draw a really good bunny.
Oh, yeah. Oh, yeah. It looks like a bunny that you would get for Christmas and then somebody took a bite out of it.
Yes. He's an angry bunny. Okay. Now, what could we call our bunny?
Jerry.
No.
Oh.
A consumer. What else could we call our bunny? A heterotroph.
Herbivore.
Ooh, I like it. An herbivore. What kind of consumer is it? Primary consumer. Do we have any other names? No. Okay, who is eating our bunny?
A wolf.
A wolf.
Alligator. Oh my god, that's a wolf.
That's a wolfigator.
A wolfigator, right. What are we calling him?
Secondary consumer.
Secondary consumer.
Heterotroph.
Okay, guys, some of you are trying to talk faster than everybody else in the room. I'm trying to let you all have a chance to think. So what's another name for it? Heterotroph. What else? Carnivore. Got it? Questions about that? Now, there is something that can work on all of these. Who can work on all of these? Decomposers. But what's another name for a decomposer? Biotic. It's biotic for sure, but what's another name for it? Heterotroph. A detritivore. Okay? Depending on what it's eating, if it's dead. Okay, now that's something you could just take a picture of and put in your group shared notes, right?
Yeah.
Yes. I can. It's so beautiful. Of course I can Instagram it. I want that preserved.
See, that bunny. His name is Jake.
I like that.
HBio it just looks like it's not having a good day. It's gonna get eaten by a wolf gator. Gets eaten by a wolf gator.
Oh god. What's up, HBio?
Okay, it's up. All right. Now, photo wasn't posted. Why not? Post that photo. I am. All right. Any questions on that? Photo's up now. You can like it. All right. So I'm just going through. Here are producers. I'm going to go through these quickly. Trees, algae, fungi. There are ones that are called chemoautotrophs. These are not using light to do photosynthesis. They're using energy from like hydrothermal vents or something like that. We already talked about herbivores. We know what they are. We know what a carnivore is. And that should be all familiar. And what's an omnivore?
Like us.
Plants and animals. Good job. And then we also talked about decomposers. Easy peasy lemon squeezy. Okay. Where does all energy originate from? The sun. The big yellow one's the sun. Okay? So energy flows and nutrients what? Cycle. Energy flows and nutrients cycle. Right? Energy flows and nutrient cycle. And you can see that in this picture right here. Does all the energy, if a tiger ate me today, if a Bengal tiger rushed in the room and ate me, would he get, ate me, and he ate me. Okay, so if that, all the energy of all the nachos I've ever had in my lifetime, and all the cheeseburgers and french fries with ranch dressing and pizza, and salad, would all of that go to the Bengal tiger?
No.
Why? I've spent, it gets lost, right? I have lost energy. About how much of the total energy I've consumed goes to the Bengal tiger?
10%.
Maybe 10%. 10% at best. So that's why when we stack up our organisms, we only have about 3 to 4 links because we run out of energy. Right? Now, energy is not created or destroyed. It just changes forms. Okay? And every time it changes forms, we lose some as heat. The energy isn't disappearing, it's dissipating as heat, so it's no longer useful energy. Got it? Okay. Now, let's see. We then started looking at food chains, and food chains is a single pathway. Algae, shrimp, fish, Miss Litton. Okay? That is a single pathway. But if it goes algae, shrimp, or whatever, fish, and another one goes to Miss Litton, and another one goes to a shark, okay? And another one goes to Dan, okay? Then, now we're no longer talking about a food chain, we're talking about a food web. Perfect. Okay. And food webs are more complicated, and we talked about that. We said there are some really seriously complicated ones. Some of your food webs start off with plants. What kind of food web is that? Grazing. Others start out with dead stuff. That would be detrital or detrital, good. And can they coexist? Yes. Right? If you eat mushrooms on your salad, you're eating out of both food webs, right? If there's mushrooms would be a decomposer, and lettuce would be a grazing one, right? So it's very likely that you would eat out of both of those. Now, we said 10% gets passed on, but we can identify what we're eating at as a trophic level. And if we eat producers, we're eating at the lowest of troughs, you could think of it like. So I'm eating at the lowest trough, which has the most energy and the most nutrients. Generally, it's what's most numerous. The exception to the rule is sometimes an algae or a plant can produce so many nutrients, it can support a large quantity of consumers. Okay? But that's this would be at the bottom of our pyramid if we stacked up each of these, right? And so then a grasshopper and herbivore would be eating, if we ate grasshoppers, we'd be eating at the second trophic level. If we ate snakes, we'd be eating at the third. And it's going just like you did before. Producer, primary consumer, secondary consumer. Producer, herbivore, carnivore. Ask the person next to you, do you get that? All right. Go in on a computer.
The name Z.
As your name Z, I want you to be something hot, like chili beans. Think of hot. I'm going to remove though because I have last class. Anything hot that's appropriate. That's appropriate. Can anybody in here eat jalapenos? It makes me like, I can't. I think I'm going to die.
Eat it with popcorn. Me too. Go together. Oh my god.
Wait,
That's so good.
jalapeno peppers with popcorn?
Yeah. It's so good. It adds like
What's wrong with you?
I got you.
That sounds terrible. Luke, no.
I think
Hot? Okay, I got it.
it's so good. And the
Paprika. An ice rink isn't hot?
If we're playing hockey, it is.
Oh, if you're playing hockey on there. Okay, I'm starting. You can still join. Okay, I'm pausing this while they work. Okay, and we're back. All right, let's see how you
The
did.
best of the best to hear.
The best of the best? Okay, here we go. Oh, so sad. You know it's written on the picture, right?
Wow.
Like each object, when you blow it up, it says whether it's a consumer or not. Okay, did anybody pick B? No, good. Okay, good. So some of you just forgot to have all of them. Oh, everything on there is a consumer except for the plants because they're what?
Producers.
Good. You could capture this. You could put it in your group shared notes in your review right now, right?
Yeah, it's gonna be a question.
Oh my god.
Oh my gosh. Which organisms are herbivores? Anything that eats the plant. In this picture, the caterpillar is eating the plant. Okay, come back to me. A frog cannot, the frog isn't eating the plant. If the frog was eating the plant, then he'd be an herbivore. What was the frog eating in our picture? The caterpillar. Yay, we got 100. Which organisms are producers? Just the flower? Oh, just one. Which organism is at the third trophic level? Tell me, who's at the first trophic level?
Flower.
Who's at the second trophic level?
Caterpillar.
Who's at the third trophic level?
Frog.
The frog, because he's eating. Okay? Ask your bio buddy, how'd you do on that? Did you get it?
I got it.
Okay, keep going, keep going. Let's finish. Okay, ecological pyramids. All you do is put all your producers at the bottom of the period. Bottom of the pyramid.
Yes.
Then who goes next?
The
Herbivores, primary consumer. Who goes next?
secondary consumers.
What's wrong with this model that we have on the board?
No
No decomposers. What else?
The sun's not there. And,
Yes.
And energy, the
That goes
release
out.
of heat.
Okay, we're not seeing the release of heat, but what else is not there?
There's more than those animals.
More than those animals, I'm looking for something
Oh,
else.
is it upside down?
10%.
Yeah, only 10% gets passed on. So if you look at all the energy here, only about, this much of the giraffe maybe would get passed on. And of that, only another 10% here would get passed on. It's not a steep enough pyramid.
True.
Okay, 10%. So that's wrong with that. Remember, organisms are doing a lot of other things in their lifetime, and so they'll lose some of that energy. So this might be a more accurate one. And generally speaking, the pyramid of numbers works. Usually there's more blades of grass than there are zebras eating the grass, right? And usually the blades of grass, all the blades of grass together are going to weigh more than all the zebras together. But the best way to represent it is how much energy is each level. There's more energy at the bottom than there is as you work your way up. Okay, we did that. You feel comfortable with this? All right, here you go. Then we just got to do the cycles, and we're good. You're welcome, sweetheart. We got this. Before I forget, what's one thing I'm not reviewing today that you are sure is going to show up on your quiz tomorrow? Additional objectives. Do the additional objectives. Where are the additional objectives located?
The calendar.
On your calendar. Okay? So, I think I can close that. If I went up on the calendar, here, let me just show you so you got it down. Go. Student review, go. Honors bio, go. Go. Okay, here is your calendar. It's your birthday. Got a little 50 cent going. All right, now, these are your objectives, right? This is what you're supposed to be, like your summary of everything that we're talking about is right here in your objectives. So if I go to this next chapter, I can see this science, look right here, describe the parts of the community, the factors that influence it, the roles of organisms within it. We just did that. The roles of competition and predation. We did that, right? Define, that was last chapter. Moving on. Okay, chapter 34, describe the different components of an ecosystem, biotic and abiotic. Describe food webs, trophic levels, and ecological pyramids. Have we done that?
Yes.
Okay, describe the components of and the importance of, we're going to review those water cycles. And right underneath it, ecology focus, ozone shield depletion. Page what?
7.
How is ozone formed? You see where it is? Right there on your calendar.
Okay.
Calendar has dates and what we do. Are you good? Are you good, sweetheart? Okay, all right. She's not responding. Okay, so let's check your answers. Yay, a hundy. Anybody thinking of something else for that one?
Oh God.
Did you miss the next one?
Yeah.
Okay.
Oh.
So, we're still at 1. The first trophic level on a food web is composed of what? Producers. 2 of you said primary consumers. What's another name for a primary consumer? Herbivore. Okay? A heterotroph. The very bottom of every food web has your producers, right? If it's a grazing food web, or your decomposers if you're at a detrital food web. And then one of you said tertiary consumers. What's a tertiary consumer? Carnivore. That's eating other, yeah. All right, and 3. In a grazing food web, the carnivores that eat the herbivores are referred to. And all we have to do is go back to that picture we drew at the very, very beginning. You should not be missing these. A carnivore that's eating a what? What is he eating?
The
Herbivore.
Herbivores or the no.
Okay, who's eating there? It's eating that grass. The carnivore who's eating the herbivore is referred to, remember, he is the primary consumer, he is the secondary consumer. This is the producer. 4 of you picked tertiary consumer. The tertiary consumer is whoever eats this guy. That would be the tertiary consumer. We practiced this several times in class. We practiced it at the start of this review, and some of you are still struggling. Okay, don't celebrate your ignorance. Okay, celebrate success. You get this. All right, next, cycles. Okay, so let's go through our cycles. The easiest one is the water cycle. Oh, wait, let me do this first. Okay, the reservoir is where it's found, right? Exchange pool is where usually an autotroph can access it. And community, it moves through the community, right?
Yes.
Okay, so the water cycle, key things about the water cycle we want to know. How much water on this planet is fresh water?
3%.
3%. Where is most of that fresh water?
Glaciers.
Glaciers. What do you call it when water comes down out of the sky?
Rain.
What do you call it when water comes up?
Evaporation.
Evaporation.
Or evapotranspiration.
What if it's coming out of a plant? Transpiration or evapotranspiration. What if this water is found underground? Groundwater aquifers. Okay? What can happen if we remove too much water from aquifers? You can get a sinkhole. How do we destroy the water cycle? Pollutions. Okay? Combustion, other cycles, can put pollutants into either the air or in runoff and drains, and then we could impact that water cycle. Okay? So that one I think you'll have down. The second cycle we discussed, bad, pollute, sinkhole, bad. Second cycle we discussed was the phosphorus cycle. Where is the reservoir for phosphorus? Rocks. How does it get out of the rocks naturally? Erosion. Phosphorus is known as a limiting nutrient, right? Meaning there's usually not enough to go around. So it regulates the growth of producers because there's not enough of it. When man adds extra phosphates into a body of water through maybe animals, fertilizer, runoff from our homes, factories, all of a sudden there's a whole lot of phosphates in the water. What are you going to get a whole lot of then as a result of that? Algae and plants, which you're like, yay, producer, make some oxygen for us. Yeah, but there's not enough to keep them all alive, so what happens to that algae? Die. Who works on them? Decomposers. Decomposers are a type of heterotroph that require what gas?
Oxygen.
They can take all the oxygen out of the lake, and then what happens to everything else in the lake when they don't have oxygen? Dies. Okay, so that's how man can abuse that cycle. Normally it just gets in plants, animals eat the plants, or they eat other animals, and that's how you get it in living systems. Okay, and decomposers work on it and recycle it back into the system. Okay, that, we talked about a specific word called eutrophication, which is over-enrichment of a body of water. All right, time for Mr. Nitrogen cycle. You totally have this. And period 4 recorded me. It's on Instagram, the whole song. Okay, it's on Instagram. Okay, and I think it's on my YouTube too. So let's do the nitrogen cycle. Do you need me to explain it first, or can we just do the nitrogen cycle?
Do it.
Here we go, here we go.
I got it.
Nitrogen fixation by nitrogen-fixing bacteria. Pause. It's going from N2 gas to ammonia, right?
Yes.
Okay, then we do nitrification. Say it again. Nitrification. So that's going to be nitrifying bacteria. And first we make nitrite, but ultimately through nitrification we're going to make nitrate. Okay, and a 3 minus. Who can use the nitrate? Plants. Now the plants have it. And then animals can eat the plants. Now it's in living systems. When the plants and the animals are going to die, who works on them? Decomposers and puts it back into ammonium. Then we do nitrification. First nitrite, then nitrate. But there are other ways to get nitrate as well. Atmospheric fixation by what? Lightning, right? And then there's another way to get it too. Man-made fertilizers. Good. How does it get back into the reservoir in the sky? Denitrification. Denitrifying bacteria take it from nitrate back to N2 in the air. Denitrifying bacteria. Nitrogen fixing, D, nitrification returns it. And along the bottom is nitrification, nitrite, nitrate. Got it? Okay. How does man screw it up? Again, pretty common, pollution. You can get nitrates, you can get nitrous oxide. Oh, there's a plant exploding in Texas as we speak, right? Yeah, just in case you're wondering. Acid rain.
It smells like a campfire, don't worry.
Yeah, I know, right? Okay, oh, I talked about this in zero period, right? I'm like, I know, I'm like, campfire. Okay, acid rain, bad on trees. Okay, last cycle, my friends.
Oh my.
Acid rain.
Carbon cycle. There's one process that removes the carbon from the air. What is that called? Photosynthesis. Most of the air we breathe is actually what? Nitrogen, N2. It's inert. We can't do anything with it. But cellular respiration will take the carbohydrates we consume and make more CO2. Burning of fossil fuels makes more CO2. Decomposition makes more CO2. The only thing that removes it is photosynthesis. So we want to have a lot of plants out there doing a whole lot of photosynthesis. If we don't have enough plants, because we're cutting them down, and we do a whole lot of burning of fossil fuels instead of using alternative forms of energy, we're increasing the amount of CO2 in the atmosphere. That increase of CO2 forms like a bubble that heat can't escape from. That is called what? Global warming, right? When it can't, and it's called the greenhouse effect, right? The heat comes in, but it can't get out. That can change global mean temperatures. It can change global weather patterns. It can affect the salinity of the ocean. Bad. Okay? All right, and so that is your last cycle. Let's do some questions. See how you do. Because you're smarty McSmarty. Don't miss these. Get hundies.
Hundies all day.
Hundies all day.
Oh my.
Got 9 questions. I'm going to pause it.
You could get 900s.
You could get 9 100s.
No.
Okay, here we go. Let's see how you did. Yay! That's one. One. Did you screw up?
No?
Okay. 2. Yay! Good job.
We up.
Do you need me to go over any of these? Are you capturing these and putting them on your group shared notes?
Yes.
Oh.
Dan, is that you?
No? I got all right.
We're good.
Come on, man.
We're good.
Dan. All right.
Who was
Let's talk about this one. The most abundant gas in the atmosphere is nitrogen. Somebody put what? Carbon dioxide. No. How much of the air we breathe is nitrogen?
70%.
78%. Nitrogen gas to ammonium is nitrogen fixation. 2 of you said this.
You silly Billy.
Oh my god.
Nitrogen gas to nitrate. Who does that? Lightning. Yay, 1.
You're such a silly.
Nitrite to nitrate is nitrification, not nitrogen fixation. That's N2 to ammonium.
You silly head.
Oh, good Lord. All of these are involved in the carbon cycle,
Yo, who's the silly head?
and all of those were true. All right, that's it, my preciouses. Study for your quiz. Do your additional objectives. I'm already proud of you.
Wow.
I will post this.
Better than my parents ever were.